I guess we can do the intro right now. So hi, everyone, I'm Jack. I work for Amazon Web Services for Open Data Analytics. This is an organization which we manage all the open source software, including Spark, Iceberg, Hoodie, Delta, all these kind of cool things. And joining me here is my boss, Ronnie.
Obviously, I was going to say only good things. No, I'm here just really to introduce Jack a little bit and talk to you about the innovations in AWS. I'm really excited to be. It's good to see everybody. My job really is to make Iceberg in AWS the best that it can be, so people choose AWS to run in. So that's really my job, and finding people like Jack and enabling them to contribute. We're good. Do you want to give it? So I'll just you don't have to bear me for a long time. It's just going to be like 2-3 minutes, just a little bit of history of Iceberg and AWS when we started with Jack at the end of 2020. I think we picked up this really nice format. We wanted to do something with open source to support updates, deletes, and everything. And we had our own engine at the time. It was Athena. And we saw it was really good to see a table format, right, that supports in a very standard way the ability to query different file formats with different engines. There were a lot of benefits, and I think a lot of people over the years have seen that, which is you standardize a lot of the metadata operation that were not possible at the time with the Hive table format that existed at the time. For those of you who didn't know, Hive had an ability to do updates and deletes and things like that, but it didn't caught on. This has a lot of challenges. If you used it, and I think I've heard a little bit of keys and tokens and stuff like that, governance is really hard to do with this particular abstraction. You have to read whole files or whole metadata, and so you're really kind of stuck. And the reality is a lot of our customers do use Hive. They use just Parquet and Hive. They do inserts, and so a lot of those folks don't want to do any sort of migration, even though it's a metadata. So they need kind of duality. So that is kind of the challenges that you have with this. Where we think we are today is the way to solve this is to introduce obviously an abstraction layer. Like everything in computer science, you put one layer more and then you solve it. And the reality is this is what we're starting to see today, including in AWS, right? You have a catalog abstraction that is meant to do more than just a table format is supposed to do. And that is to do governance in a little bit more finer detail, abstract more of that capability. So what we see with this and the benefit, and this is Jack will touch a little bit about some of the innovations that we're doing today, is not only we need to continue to innovate on the table format itself, which we still access it, we want to innovate on the catalog side as well. Benefits, obviously, more fine-grained governance, and you're starting to see it in things like Unity, Polaris, Glue Data Catalog with lake formation, things like that. But you can also start doing more interesting things. You can do on-the-fly conversions of the data itself, so it allows you to abstract whatever is on the other side, not just for governance, but if you want to plug in Hive, for example, you can start doing things like that. Can you guess, the bad decisions or not as ideals decisions here is now you need every engine to speak every proprietary catalog that exists out there, which is not what a lot of customers out there have. They have a mesh of a lot of different capabilities, and they want all of them to interoperate with each other. The other thing is it's not such a great idea to split an engine in two and have something that scans and returns it. There's good trade-offs with that, and so how do you solve that sort of problem? So where we see the future going and where we in AWS want to continue to see the community innovate is really try to find a way where the REST API of Iceberg becomes that unique standard. We don't want to see that proprietary API lollipop in there. We believe that's a possibility actually to lock in, and our customers don't want that. They want to be able to come in, use whatever catalog they want. They want one single engine talking to all of them. And if they have another data source that's not exactly Parquet or Avril, whatever it is on the cloud, they also want to be able to connect to that specific engine. So that's what they want to do, a common interface, and this is where we're actually actively working to do. We believe it allows for a lot of innovation still on the server side, like caching, performance innovation, a lot of generate better enforcement so you don't have to split anything like that. So Jack is going to talk to you a little bit. Actually, before we go there, In terms of engagement, we've been doing this for a really long time. Jack has been at the forefront of that, so I think he underscored his contribution here. We started, in 2020, we started engaging really on the table format, and then we went over to now doing a lot of innovations on the catalog side, a lot more. So here you see a little bit of a timeline, and he's going to talk a little bit about exploring what can we do in the Iceberg API, how do we abstract the read path. So he's going to talk to you about a plan and pre-plan innovations. The write path, I heard a lot of the previous talk, the write path are problematic. It's in the spec itself. There's problems in the REST API as well. And so that's an area that we're actively looking to add more things. Also, we're adding a lot of contributions and discussions with the community around governance, fine-grained access control, and how do we do that in a standardized way. With that, I'm going to drop to the guy who really knows what he's talking about.
Thank you very much. And as Ronnie said, we have been innovating in the Iceberg community and keep contributing features. What I'm going to talk about next are two major features that we recently contributed to Iceberg, one in table format and one in REST catalog. So for the table format side, we are looking into what we call the object storage layout v3. So for people who don't know what is the Iceberg object storage layout, it is specifically designed for object storage like Amazon S3, because S3 is not a very standard storage file system, but it is behind the scene of B-tree, and it partitions data by a key prefix. That means when you create an S3 bucket, originally all the data resides in the same physical partition behind the scene, and as the data grows with more and more keys added to the bucket, S3 start to look into more and more prefixes in the bucket and try to create more physical partitions behind the scene to host your data. So when you don't have as many physical partitions behind the scene, you are more likely to get throttled when you make lots of requests to S3. So the goal of Iceberg is that because Iceberg records all the file paths in the manifests, so we have the freedom to define file paths in whatever way we want. And so we want to spread for S3 use cases the prefix to as many different values as possible to maximize the throughput and minimize throttling. Today, this has been a feature for a long time, and people can enable that with this table property called write object storage enable equals to true, and you can also choose whatever prefix you have for putting all the data you have. And the initial version of the layout does the following. It calculates the memory hash, which is an integer of the original file path, and then it encodes it into an 8-character hex string. And then the final path is defined as data location plus the hex string plus original file name. On the left is an example of what it looks like. And there are two problems of that that we found over the usage of that. The first issue is that the hex string is left padded, and it results in an uneven distribution because there are data that are padded with 0, and so there are more prefixes with zeros compared to all the other prefixes, which is an issue. And also, because it is an integer hash, it doesn't really have all the values of the hex, which should be 0 to F. But actually, if you look into your bucket in maybe old Iceberg tables, you will see only 0 to 8 that are leveraged as a prefix. So we did a fix of that afterwards, which we call the V2 layout, is that we reverse the hash value so that it doesn't have the issue of just 0 to 8, so it will have all the ranges of the hashes. And we changed that into base 64 instead of base 16 in order to maximize the throughput. And because we changed the base, it only needs 6 characters instead of 8. So today, if you use the object storage layout, you will see some kind of prefixes like the one on the right. So the problem that we realize is overall it works great, and customers are happy with the throughput, and there is no throttling happening. But in the initial writing phase, it is getting throttled much more than before, actually, because S3 is trying to provision the maximum number of physical partitions behind the scene when you are getting throttled. So you are getting throttled for a longer time in the initial write comparing to actually you were before. And also, we realized the issue, which kind of existed in V1, but kind of is amplified in V2, is that the orphan file removal process is becoming very inefficient, because that is the only place in Iceberg today that still uses the HDFS file system interface, because it has to do a directory listing to list all the files, and then do a comparison of that with the actual files that are on the table to remove all the orphan files that are not referenced by the table. So in this case, in the worst case, you have to list actually 2 raised to 36 directory. Usually what that means is that you are going to list every single file in the directory, because HDFS directory listing has to list all the files in all the first layer directories in a single call before it can terminate. So even though we implemented distributed file listing in later Spark versions in Iceberg, it didn't help at all, and you still have to list all the directories in a single thread, which becomes very slow and sometimes timed out. So recently in the PR I linked here, that we added the new version of the layout, which is V3. This has been a collaboration with S3 teams and is a design that has been load tested to work very well. So instead of using base 64, now we switched to a totally different direction, which is using base 2 with all these binary values, so that instead of directly maximizing to the biggest throughput you have, it actually is going to look into the first bit and second bit that gradually grow the throughput of the bucket over the time. So this improves the initial write experience, and also makes the usage of the S3 physical partition more intelligent behind the scene. And to fix the directory listing problem, I think we believe that the proper fix is to use the file IO's new support prefix listing interface. But for backwards compatibility purpose, we add these additional slashes so that in the initial listing of the first layer of directories, you are going to list 2 raised to just 4 number of directories, and the subsequent ones are going to be listed in a distributed manner. The reason we have 3 slashes here is because the Spark configuration by default is to list 3 layers of directories in the driver, and then do the subsequent listings in the workers. And to work with migration experience, this is going to be enabled default in 1.7 in Iceberg. And if for people who are having the object storage layout enabled by default, you are going to be automatically having this kind of layout in the future. And if you see throttling, what we added is that we added another retry improvement in the S3 file, so that you can set the retry to very high to live with the initial phase of the migration if needed. But in general, we don't see any throttling after S3's load test. And we have worked with the S3 team to make sure these magic numbers 20 and 33 all works for most of the customers. So that is for the file format level of the innovations for improving S3 resilience and performance. And the other innovation we recently merged is the REST catalog innovation for the plan table scan API. The major use case is that today, if you try to do Iceberg table scan, you see this is a piece of Java code that people usually write, which is you load a table, and then you do table.new scan, and you pass in some filter and select, then Iceberg will pull in all the manifest list, manifest files, and then do the planning on the client side. And what we are thinking is that, can we do this actually at the server side, because we believe this will be more, unlock many server-side optimizations to be more performant, and also unlock a few key features I'm going to talk about afterwards. So the general idea is that it will kind of mimic the Iceberg 2-level client-side planning. And in the initial phase, the engine is going to tell the catalog that, actually, I'm going to start planning the table with kind of the same information as I just showed in the past, that I'm scanning table T1, for example, with some filters and selecting some columns. And the catalog is going to give me a list of what we call plan tasks. And after that, the engine is going to, for every single plan task, get a specific list of files to be read, and then it will go read those files. So this is the kind of the end 4 APIs we come up with the community after very long discussions. We finally merged these changes. I think the actual implementation is going to be in 1.8. We are still kind of reviewing the implementation PR. But we have one API which does the plan table scan, does the initial thing of starting the plan. And because the planning might take a very short period of time, or it might take long. We have this fetch planning result and cancel planning to incorporate the asynchronous planning use case. And then there's a fetch scan task API, which can recursively kind of fetch scan task until it is exhausted. And the more details are in this PR if you want to know more details. So there are 3 use cases that we see engines can implement against these 4 APIs. The first case is that you just do very simple scanning, which directly returns you a list of files. So you are just going to invoke the plan table scan API, and then it will return you a list of tasks. And secondly, if you are going to return more things, maybe one response does not give you everything, then you can leverage the API of fetch scan tasks so that it will return you the planned tasks and it will give you more tasks over the time. And one key feature that it unblocks is what Ronnie was talking about, which is that is cross-format interoperability, because this will essentially allow us to support reading table formats like Hive tables, Delta tables, Hoodie tables behind the scenes through these APIs. This graph shows an example of how you can read a Hive Parquet table behind the scene, because you can treat Hive get partitions as the response of the plan table scan API, and then for the fetch scan task, you can do listing files within a directory. You can also do pagination behind the scene through the catalog server. The third case, which is the most complicated case, which is asynchronous planning. That is, you, in addition to have the plan table scan and the fetch scan tasks, you also will wait for the initial table scan planning to finish, and then that will give you initially a state, and you will keep waiting for the state until that is complete, and then you do what you did for case 2. And that unblocks a key feature, which is governance enforcement behind the scene. Because you can imagine we can even hook up, this is kind of an extreme case that I'm not recommending you implement that way, but in an extreme case that you can hook up a governance enforcement engine, and that can even run the scan through and produce the files that are desirable on the fly, and that can be returned back as the planning result and subsequent tasks which it can exhaust. So by doing these planning APIs, we are essentially moving the client-side features to the server side, which can unblock these interoperability use cases and governance use cases for many enterprise users. So there are some upcoming features I also want to mention for both the table format side and the REST catalog side that we are going to merge probably in the next 1 month or 2 months. For the table format side, we are actually doing a lot of improvements on S3 file I/O for especially read performance. One key thing we kind of wanted to do but haven't been done, finally we are doing that, is integration with the AWS CRT client, Common Runtime Client. That is a Rust native, C++ native client that will be more efficient in reading in general. And we are going to do features like small file prefetch, auto detection of sequential read, and quite a few Parquet optimizations when the file name ends with Parquet, that we are going to prefetch until the row group boundary, and we are going to prefetch and cache the footer, because we know that is what people always have been doing, and we want to optimize that code path much better in S3. For the REST catalog side, we have kind of 3 big proposals we are pushing in the community. The server-side data commit, I think it's actually called fine-grained metadata commit, which is the official name, that we are currently pushing. That should go in, we are expecting in the next 1 or 2 months, which will enable kind of the write-side equivalent of the scanning API so that you can do the writes also on the server side. And we are working with quite a few people who are interested in doing secure views of access decision exchange, and we believe that it can actually fulfill many use cases such as low-level security filter and column masking behind the secure views. And we have another proposal for secureable objects, grant and revoke APIs that we are also pushing in the open source, that we are going to see more updates on that. Yeah, so in the end, we are committed to improve Iceberg experience on AWS, and we are fully committed to also contributing everything we can to the open source and to make the experience better. Thank you very much.
Hello, awesome. Thank you guys. Anyone have any questions? Hey, thanks for the great talk. My question is, Object Layout v3 is Iceberg 1.7.
Yes.
What is the timeline for that?
I think we are voting for that. Yeah, right now.
Okay, I see. So, any specific dates?
Did the vote pass? I didn't check. Okay, so it's voting. So maybe next week.
Okay, so let me try the other angle.
Sorry, what?
When can we expect the performance benefits related to Object Layout v3?
So I think there are two different groups of users. For the user who are not on that but have the data on S3, we will say that if you enable that, then you should see throttling going down a lot. That's based on our experiment data. For people who are already on object storage layout, that is more for new tables that we are expecting to see less throttling when you do the initial writes to the table. But if you are already using the table for a long time with object storage layout, then likely your partition is already your bucket is already fully partitioned behind the scenes, so you shouldn't
Okay,
keep
I
worrying.
see.
Yeah.
So what you're saying right now is that if we've been using that for quite a while, there's no reason for us to recreate the table and sort of backfill them using the v3 at that point?
Correct, yeah.
Okay.
But I guess as the data gradually being optimized and you are using the new library version, then it will gradually all become that layout automatically.
Okay, I
Yeah.
see. Thank you.
Can you talk more about Object Layout v3 and there are 3 levels of directories, and is each table a directory? I mean, can you just explain that a little bit more?
Sure. Let's go back to that. So in general, it is 20 characters of the binary hash, and if you ignore the slashes, right? So within table, it will be there will be a prefix like that, and then the original file path name. The reason we added the slash is because that helps with the open file removal process. Because by default, I think open file removal will try to do directory listing on the driver for 3 levels of the directories. And then for everything nested even further, it will distribute to the workers to do further listing. So this is kind of the ideal layout to make that happen.
So just to confirm, if you're using list keys with prefix, then the slashes don't matter, right?
Correct.
Okay,
but
thank you.
yeah, but that doesn't happen right now today.
Hello, Jack. My question is, and this is for the both of you, I guess. If you had a magic wand that will grant you one wish about the project, the community, whatever, I guess in the next 6 months to a year, what would that be?
I guess I hope we launch V3 as soon as possible, because typically customers ask for a date, just like what just happened, but we cannot guarantee a date in open source. So hopefully that goes smoothly. Yeah.
For me, it would be consolidating the standards a lot more. I think we know there's efforts about consolidating the 2 popular formats out there, like Delta and Iceberg. I think there's some efforts in figuring out a way to make them work, interoperate with each other. And I hope in the next year the community can get together and figure that out. The second one is the same for definitely we do not want to see is the proliferations of catalogs as the next place where vendors are trying to differentiate, and we have another battle for the next 3-4 years where everybody's trying to do their own thing. So hopefully we see a lot of everybody in the community and all the vendors come together to create a single REST catalog API like we are proposing that supports not just table formats but views, other objects, governance, find your access control, all the things that we're seeing each one trying to have through proprietary API. So if I can wave a magic wand, it would be like everybody kind of pitching in and making that a reality.
Thank you. I'm curious about the table plan API. When the table is really large and have huge amount of data files to pass it back to the client, how do you handle that?
That's actually one big use case we are trying to enable through the server-side planning APIs because, first of all, we see it is very slow to run on client, especially for large table scans, that even the planning will take minutes to complete, which is not ideal. There was an implementation in Spark to use Spark to distribute the load. But we did the performance testing of that, and actually we saw the performance regressed in the standard benchmark because, and our conclusion was that Spark workers are too heavy weighted to just do that. And actually, a kind of web service architecture is more ideal because these are very small tasks that you can easily distribute to a bunch of server nodes that doesn't need to be very heavyweight, just like Spark workers, and you can actually do massive parallelized planning behind the server. So hopefully that will help mitigating the planning time for the big tables. So that is one thing from the performance perspective we are trying to enable through the plan table APIs.
A quick follow-up is, so even if the server side can like load the table real quick, but and plan real quick, but how do you stream the data back? Like on the way, client can also have enough time to consume that, and the session is like still maintained.
I guess maybe I didn't fully get your question because the planning API are just for planning the files, right? They are not really reading the files yet.
Just pass back other files, like a list of files back. It may take a few trips, and then you need to maintain that session over time.
I think the goal here, imagination is what we are trying to do to support cases like Hive, because we know there are customers that have millions of partitions that cannot be listed in a single call. But in general, this is the design of the planning API is more for like I don't know sharding if it's the right term, but sharding-based strategy, which is you are not using pagination, but you are kind of just distributing the work directly trying to distribute the work in a way that a single node can complete in a reasonable period of time, and then return all the results back. For example, we are based on kind of our internal testing. In many cases, you don't even need to return things like the statistics, for example. That usually takes a lot of time to generate. So those typically helps saving the round trip. And you need to have a large enough server, I think, to usually to have a server fleet in order to see the performance improvement. And also testing against a large enough table with enough number of files. Yeah.
Thanks.
Can I ask a question about the REST API? Like, what's the current direction on putting more secure feature on the REST API? Is it a direction to put more secure feature on it, or put this on the catalog feature?
So we have the proposal actually put up almost a year ago for what we call access information exchange. That we were originally trying to propose some different ways for doing like row-level filters, column masking, these what we call fine-grained access control. And one of the approach was secure view, which seems to gain more support for different people. So that is the current direction we are pushing, which is you have a secure view that is defined, which can contain, for example, I'm reading table A, and I actually have a row-level filter that defined against the table A. So when I am reading the table, actually the catalog will say this is a secure view with these filters, and then I will read the view, and then it will redirect to have those information applied against the secure view. And because every single engine kind of knows how to process the secure view in the right way, so we are hoping that is the right entry point for integration for that. And on the other side, for permission control, the other things, we have the grant and revoke APIs and secure objects. Hopefully that provides some kind of standard. That's our hope, so that people have mostly similar verbs to define privileges and standardized APIs to do grants and revokes. Yeah.
This is an area probably that as a community and as stakeholders in the Iceberg community, you guys can go and see the PRs that we actually put forward. I think Jack is right. Like we, for example, in lake formation and glue data catalog,
Yeah.
we have this capability of multi-dialect view that we call them, that you can actually use to have fine-grained permissions. And we were advocating for that in the Iceberg community. As you said, part of our plan is really to see a single API. And eventually the community, after some discussion, adopted it, you know, with contributions from other partners to say, okay, you know what, I think this is a reasonable direction. Let's return that view every time you query a table. And now the engine can apply, you know, the right, you know, filter because it's arbitrary SQL. And it can be of the dialect of the engine that's calling it. We still have to figure things out, like how does the API know that that engine is trusted, because you don't want to pass in all this information to somebody that you don't know who it is. And so there's still a protocol that needs to be figured out there. In terms of the of the grant, revoke, like more of the, you know, standard SQL, ANSI SQL verbs that you want to have, like I want to grant, modify, or merge in a table. I think that's an area where the community is still not really are of two opinions, I guess you can say. One opinion is we don't want Iceberg to be so opinionated that everybody now has to comply with it, because we all know ANSI SQL and implementation have challenges. And we just offer like enums and strings in it, and we let the the catalog side decide how to implement them. Or we go into the more, you know, okay, here are the verbs that you're going to have, and you know the catalog has to now semantically guarantee that those are the way you're going to enforce them. And I think we're, you know, it's a good opportunity for everybody who's seen that PR to kind of throw and say, okay, I think this is a good approach or not, or how we're going to make it work with different, you know, engines and different catalog implementation. I think we're still early in that, but that's exactly what I was talking about where we see this.
I think, thank you.